Hi guys! I'm back with another video. Today, I am tasked to create a video demonstration of my own program that will display a physics or math problem on my LCD screen. So let's get started! The objective of this task is to demonstrate the functionality of an LCD display using a microcontroller. Here are the guidelines. First, create a simple physics or math problem that involves calculations with at least 3 variables. Let the given variables be presented by Greek letters, which you will need to create custom characters for this to be displayed properly in your LCD display. Add 2 tact switches and connect it to your microcontroller. These 2 tact switches shall be connected to pin number 8 and pin number 9. These 2 shall be programmed to be used to scroll down and scroll up to the text being displayed on your LCD screen. When the last line is displayed and the scroll down is pressed, the program must be able to go back and display the first line. However, if the first line is displayed and the scroll up is pressed, the program will not respond in this input. The worded problem together with a complete solution must be able to be displayed on your LCD screen with the option to scroll up and scroll down using the text switches. Each line in the problem must have a maximum of 16 characters only. Show your name in the second line. Let's start by doing the codes of our program. For this one, we will be using the Liquid Crystal library on the Arduino application. Then, we will create the Liquid Crystal objects. Next, we will designate our scroll up button to the 8th pin, and the scroll down button should be on the 9th pin. Now we have here on how to create our symbols. The symbols that we will be using are the up and down arrows, the charge, the current, the time, and the repeat symbol. Here is the symbol for the up arrow. Well, this one is the symbol for the down arrow. We will be using the small letter delta to represent the charge. The small letter epsilon stands for current. And the small letter tau represents the time. And here is our repeat symbol. Next is the void setup, where we initialize the LCD and its dimensions. Here's the debouncing functions for all the buttons. Then the void loop, where we will write our main program and everything that we want to display on our LCD screen. Write our problem and solution here, and we have 21 cases all in all. Making the codes. Now let's move on to the materials that we will be using. First is the Arduino Uno and its cable. Then the breadboard, the jumper wires, the resistors, the 2 tact switches, and most importantly, the 16:2 LCD. It is essential to familiarize with the pinouts of the LCD. It has 16 pins with soldered pin headers on it. The first one is the ground pin. Next is the VDD pin, which we connected a 5 volts pin on the Arduino board. Then we have the VO pin. The RS pin, or the register select, the RW pin, or the read or write pin, the E pin, which enables the writing on the register. This D0 to D7 are the data pins, and the last two are the anode and the cathode pins. Here is our schematic diagram. This time, we are ready to set up our components since we already have our codes, our schematic diagram, and our materials. That's it for today, guys. I hope that you have learned something from our experiment today. Thanks for watching!